In this presentation, we will see the different kinds of volatile and non-volatile memory in a computer. An electronic memory is a necessary element in a computing system which helps them to store the data and instructions required for performing all their operations. An electronic memory can be broadly classified into volatile and non-volatile memory. A volatile memory loses data when the power is turned off, whereas a non-volatile memory retains its data even after the power is turned off. The main example of a volatile memory, as we all know, is random access memory or RAM. This RAM actually serves as the main memory or primary memory of a computer. There are two main types of RAM, SRAM and DRAM. Major examples of non-volatile memory are read-only memory or ROM and flash memory. ROM may be of types PROM, EEPROM, EEPROM, etc. And flash has two main types, NAND flash and NOR flash. Let's start with the volatile memory called random access memory or RAM. When we say about the specification of a computer, RAM and hard disk memory are the two types of memory that we see first. This RAM actually serves as the main memory in a computer. It is known as random access memory because the CPU can have very fast and direct access to it. Not only that, the CPU can randomly access any section or any location of the memory. It is possible to read from a RAM location and can also write to a RAM location. A RAM chip can store quite a lot of data in GBs. RAM is available in two types, dynamic RAM or DRAM and static RAM or SRAM. This dynamic RAM is actually the main memory in a computer. The static RAM is mostly used as the cache memory. Now let's see how the dynamic RAM or DRAM works. Each DRAM memory cell consists of one transistor and one capacitor for storing a single bit information. For writing a data bit to the memory cell, the capacitor C is charged or discharged through the transistor. For this, the transistor is turned on using the word line and an appropriate voltage is applied to the bit line. When the capacitor is charged, it means that the information stored in the cell is 1. When there is no charge on the capacitor, then it means that the information stored on the memory cell is 0. For read operation, the charge stored on the capacitor is read using a sense amplifier. Thus, a dynamic RAM memory cell can perform both read and write operation. The main drawback of this memory is that the capacitor leaks charge over time. So, in order to maintain the data stored in the memory, the capacitors must be refreshed periodically. Static RAM or SRAM uses 6 transistors for storing a single bit of information. That is, each memory cell has 6 transistors, out of which 4 of them are used for the data storage and 2 of them, T1 and T2, are used for the control purpose. A simplified circuit of static RAM memory cell will be as shown in the figure, where 2 inverters are connected back to back to form a latch. The 1-bit information will be stored in this latch. Here, there are 2 bit lines connected to the latch through transistors T1 and T2. These T1 and T2 transistors are actually used for the control purpose. The static RAM memory cell can also perform read and write operation. For reading the data stored at the latch, the word line is activated, which turns on transistors T1 and T2. Then the bit values at points A and B are transmitted to their respective bit lines. The sense circuit at the end of the bit lines sends the output to the processor. For writing the data into the cell, again the word line will be activated, which turns on T1 and T2. then the data bit to be written will be sent to the latch by the bit lines. Hence, static RAM gives very fast access to the data, but its size is relatively larger and it is expensive too, and hence it is mostly used as the cache memory. It has larger power consumption, but because there is no capacitor involved, no refresh cycle is needed. Now let's move on to the non-volatile memory types. The popular one is read-only memory or ROM. From the name itself we know that only reading operation is possible from a ROM location. It also uses random access method, but the difference is that it is non-volatile. That is, it retains the data even when the power is down. It is used to store the startup instructions for a computer. It permanently stores instructions for the computer. ROM chips store only few megabytes of data. The different types of ROM are mask ROM, PROM, EEPROM and EEPROM or EEPROM. The mask ROM is the conventional ROM which has pre-programmed instructions at the manufacturing process and they cannot be programmed by the user. PROM or programmable ROM, it stores the programs and cannot be erased, but it can be just once programmed by the user. EEPROM or erasable programmable ROM, the data can be erased by exposing them to UV light. And in EEPROM or EEPROM, that is electrically erasable programmable ROM, the data can be erased by exposing it to an electric charge. Out of these, the EEPROM or EEPROM are used for storing small amount of data in computers. They are widely used for embedded microcontrollers. EEPROM or EEPROM is actually a user modifiable ROM whose contents can be erased and reprogrammed using electrical signals. The advantage of EEPROM is that it can erase any byte of memory at any time, and they need not be removed from the computer for modifying data. They can read, write, and erase the data at the byte level. Another non-volatile memory type is flash memory. A flash memory is a variant of EEPROM. Its structure is similar to that of a EEPROM. Its advantage is that it can be erased and programmed as per the user's needs. They include USB flash drive and memory cards. Flash memory is a high-density memory because it requires only a few components to make up each memory cell. They are of two types, NAND flash and NOR flash. They offer more data storage than EEPROM with high density and high speed. Now let's see how the structures of these flash types look like. A flash memory uses floating gate MOSFET transistors as its memory cells. In NOR flash, each cell is connected in parallel to the bit lines. The data can be read and written individually, that is at the byte level. The connection resembles that of the transistors in a CMOS NOR gate and hence the name NOR flash. Whereas in a NAND flash, the cells are connected in series so that the information can be read, written and erased only in the entire block level. And the connection again resembles that of a CMOS NAND gate and hence the name NAND flash. In a flash memory, the entire memory is arranged in blocks. The bytes are combined together to form pages and the pages are arranged to form a block. In NOR flash, the read and write cycles can be performed in the byte level or word level, but the erasing of data can be performed only at the block level. It has random access function, and because of its high density and fast read speed, the NOR flash memory can be used as the program memory in most of the microcontrollers that we see today. A NAND flash memory array is actually grouped into a series of blocks. So if you want to erase data, we can only erase a whole block of data. Thus, the reading of data can be performed at the page level, the writing of data again at the page level, but the erasing can be done only at the block level. So NAND flash has fast write and erase cycles. It is the most common type of flash memory used, and it is one of the fastest growing data storage technologies these days. Whereas in NOR flash, random access is possible because the read and write cycles are possible in the byte level, hence byte programs are possible. It is used as a replacement of EEPROM, mainly used as the program memory in microcontrollers. A NAND flash memory is similar to a hard disk drive. It is page-based and it is suited for the storage of mass sequential data. So the applications include USB flash drives, SD cards, it is used in all removable cards, etc. And that's it. Thank you.